Hello everyone. So welcome you all at Lucky's Sir Unlimited Study Zone. We are starting here with the previous year questions paper with the different chapters. First question: depict the variation of electric and magnetic field in electromagnetic wave as it propagates along z-axis. Okay, so what is the question here? Depict the variation of electric and magnetic field in an electromagnetic wave as it propagates along z-axis. So remember here it is given the direction of propagation. So direction of propagation is here is z-axis. Clear? The plane electromagnetic. So this is the first question. First part of the question, as it question is of 3 marks. Okay. So you will be given 2 marks. First marks for this one part. Part number one. In a plane electromagnetic wave in free space. Yes. In the plane electromagnetic wave in the free space, the electric field oscillates simultaneously with a frequency of 1.5 into 10 to the power 10 hertz and with the amplitude of 36 volt per meter. To find first what? Find the wavelength of the wave, and second, amplitude associated with the magnetic field. Done. So student, here it is given the marks distribution. First, depicting the variation of electric field and magnetic field on the electromagnetic wave. As 3 questions are there, so you will be have given 3 marks allotted for each. In the first part of the question, there is depict the variation of electric and magnetic field in an electromagnetic wave as it propagate along z-axis. So the direction of propagation is z-axis. So be sure that you have make a z there. Okay. So make the direction of propagation along z-axis. So this is the direction of propagation. Got it? Okay. And if the direction of propagation is along z-axis, then magnetic field and electric field will be perpendicular to the z-axis. That means one of the field will be in x-axis and another will be in y-axis. So please check, electric field is in x-axis and magnetic field is in y-axis. Clear or not clear? So there are two mutually perpendicular fields. One of the field, electric field, you have to take in on either on x-axis or y-axis. You can any of the direction either on x-axis or y-axis. Okay, but it should be perpendicular to the z-axis. Clear? Okay, then magnetic field. Magnetic field is represented by capital B. So B is the magnetic field, right? E is the electric field and B is the magnetic field. According to the diagram, E is here along x-axis and B is here along y-axis. Clear or not? Yeah. So magnetic field and electric field having same wavelength, having same amplitude, okay, having same frequency. Clear or not? Now, find second question. What it find? Second question is about find the wavelength of the wave. So you know the maybe you know the formula. What is the wavelength formula? Yes. In previous class, I told you V equals to lambda equals to C upon nu, C upon F. Yes. So this is exactly nu. So V equals to C equals to nu lambda. C equals to nu lambda, right? So lambda is equals to C by nu. C by nu. Nu is the frequency. So C is the speed of light, that is equals to 3 into 10 ki power 8 meter per second. Clear? Divided by nu is the frequency, that is equals to 1.5 into 10 to the power 10. And you will have your answer 2 into 10 to the power minus 2, that is equals to 0.02 meter. So guys, this is the first question, can be solved with a formula, right? C equals to V equals to nu lambda or C equals to nu lambda. Okay. V equals to nu lambda or C equals to nu lambda. V, whenever any medium is there, then you apply V equals to nu lambda. Okay. Or you can also apply V is equals to F lambda. In the place of nu, you can also use F. So V equals to F lambda for if any medium is given. But if vacuum is given, then the speed of light becomes C. So that time you can apply C equals to nu lambda. Okay. So here the question is about electromagnetic wave. Obviously, the electromagnetic wave traveling in the with the speed of C, speed of light. So you have to apply C equals to nu lambda. Clear or not clear? See, yes, but if you have given any medium, then you have to apply V equals to nu lambda. That time you have to apply V equals to nu lambda. Now, second part of the question, what is the amplitude of the associated magnetic field? Okay, what is the amplitude of associated magnetic field? So you know the formula amplitude. Yes, what is formula, right? The formula C equals to E naught upon B naught. Okay, E naught upon B naught. Yes, C is equal to speed of light equals to E naught upon B naught. Yes, yes. E is E naught upon B naught. C is equals to E naught upon B naught. Clear? So B naught, the peak value of magnetic field may be written as E naught by C. Okay. So B naught is equals to E naught by C. By this formula, you can figure out B naught. Now place the value. What is E naught here? In the diagram or in the question you have given. Yeah, E naught is given 36 volt per meter. Okay. And place the amount of light 3 into 10 to the power 8 meter per second. Yes. Clear? Exactly. Yes. 12 into 10 to the power minus 8, that can be written as 1.2 into 10 to the power minus 7. And the unit of magnetic field equals to Tesla. Right? So student, mainly two formulas are here. Okay, you have to focus on that. First formula, right? C equals to nu lambda. First formula, very important. C equals to nu lambda for electromagnetic wave. By this formula, you can evaluate either wavelength or frequency. Second formula, what? C equals to E naught by B naught. E naught by B naught. E naught means the peak value of electric field and B naught means the peak value of magnetic field. Clear? So you can find either E naught or B naught using the same formula. Okay. Here it is asked the magnetic field value, but it may be asked electric field value also. Done. Okay, guys. Coming to the next question, number 23. Yes. Look, depict the variation of this one is done. It is done. Sorry. Yes. Question number part B of 25th. An electron of mass equals to 9.9 into 10 power minus 31 kilograms. So first, very clearly, like, write all the parameters that you have given. M equals to 9 into 10 to the power minus 31 kilogram. Before doing the numerical, must see that whether all the limits are given, all the units are given in SI system. Like here it is given kilogram, so it is fine. And charge on the electron, that is denoted by Q, is equals to 1.6 into 10 to the power minus 19 coulomb, is moving in a circle with a speed of 3.2 into 10 to the power 7 meter per second. So speed of the electron is given by 3.2 into 10 power 7 meter per second. Remember student, here it is one more important point is given, is moving in a circle. Yes. So when an electron is moving in a circle, then what is happening there? That necessary centripetal force provided by magnetic force. Okay. So that time we have to apply this concept during motion when the electron will moving in a circular path. Remember, when there is a uniform magnetic field and electrons enter perpendicular to the magnetic field, yes, the angle between B and V equals to 90 degree. Clear or not? Yes, 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 yes. Some more concepts are there. Write them. Whenever the angle between magnetic field and velocity vector is 90 degree, then the charge will move in the circular path. Clear? So it is the necessary condition that B should be perpendicular to V. Okay. So the magnetic force FB is equals to centripetal force FC. Clear? This is the condition. FB is equals to centripetal C. So tell me, what is FB? What is magnetic force here? What is magnetic force? Yes. What is magnetic force on the charged particle? It's Lorentz force, that is equals to QVB sine theta. Clear, students? So it is equals to QVB sine theta. And here the value of theta equals to how much? 90 degree. Okay. So sine 90 becomes 1. And what is the centripetal force? Tell me the value of centripetal force. Centripetal force. Centripetal force. Without centripetal force, you cannot imagine the circular motion. So centripetal force is provided by the magnetic force. But what is the amount of centripetal force? It is equals to mv square by r. My dear, remember these concept of class 11th. These are very important. Okay, mv square by r. Clear? Now 1v and v get cancelled out, and sine 90 becomes 1. So q into b into 1 equals to m multiplied by 1v by r. So r equals to mv upon qb. Got it? This is the derivation for the radius of the circular path. Okay, r equals to mv upon qb. Now apply this formula, guys. Okay, so you apply this formula, r equals to mv by qb. Place the value of mass here, the velocity here. Okay, this is q and this is b. B is the applied magnetic field. You will have your radius equals to 0.4 meter. Clear or not? Okay, then after second question of 1 marks is to find its frequency of rotation. Okay, so formula for frequency of rotation. Yes, formula for frequency of rotation, you know, speed equal to distance upon time. So time is equals to distance upon speed, and frequency nu is equals to f is given by 1 upon time period. So it will be v upon 2 pi r. Clear or not? So v upon 2 pi r. So v we have given and radius we have calculated. So place the values here. So v upon 2 pi r. So place the value of v 2 pi and r just we have calculated as 0.4 meter. So you will have your answer 4 upon pi into 10 power 7 hertz as frequency. Clear? Energy of the particle is quite simple. That is equals to half mv square. Okay? Energy of the electron. Okay, equals to half m and v square. So place the values of here r square and you will have the your answer. Done. Okay, student. Now we have to do the question number 28. Let's read the question. A rectangular loop. Yes, very carefully read the question very carefully. This is of 3 marks. A rectangular loop of 4 and 5 centimeter. Okay, so the length is equals to 4 centimeter and breadth is equals to 5 centimeter. Okay, so you have a rectangular loop of 4 into 5 centimeter. You can take this one as of wire carrying the current of 0.5 ampere. So this is length, this is breadth, and the current is given I is equals to what? 0.25 ampere. You can write it 1 by 4 ampere also. Yes or no? Because 1 by 4 becomes 0.25. Is placed in a magnetic field. Okay, this one is given your magnetic field. Okay, this is your magnetic field in vector form. Remember, concept of vector is important, becomes important here as it is given in vector form. So here it is given the amount of magnetic field that B equals to, given B equals to 0.20 I cap Tesla I cap and 0.50 Tesla K cap. So make it like this: B equals to 0.2 I cap plus 0.5 J cap, and outside the bracket it is Tesla. Clear? Such that the outward unit vector normal to plane of the loop is equals to this. This is given what? Outward unit vector. This is given you n cap. Okay. This is given you n cap. Normal vector to the plane of the loop is given by 0.80 I cap minus 0.60 j cap. This is the direction of normal unit vector 0.80 I cap minus 0.60 j cap. Okay. Do not write the after decimal 0, only it will be 0.8 I cap minus 0.6 j cap because 0.60 is equal to 0.6. Clear? Okay, now find the magnetic moment of the loop. Okay, first thing you have to find the magnetic moment. Usually we taking the magnetic moment as capital M, and we already have read the formula of magnetic moment of the loop and torque acting on the loop. Okay, so two formulas incorporated here. First find the magnetic moment of the loop and second torque on the loop. Start. So student, first you have asked to find the magnetic moment of the loop. As we know, there is a single layer loop. So for a magnetic moment, m vector, that is equals to n number of turns I into a vector. Okay. The direction of magnetic moment is along the area of the vector area. So m is equals to nia, as only here one direction, sorry, one loop. So it becomes m equals to ia. To apply the first formula, m equals to I vector a. Okay. So magnetic moment equals to m times of I times of vector a. Now you have to put vector form of a area into terms of vector. Any quantity, like if you have a quantity vector a, any vector quantity constitute two things. First, its magnitude and its direction. As you know, the direction of the area vector is along the perpendicular unit vector. Clear? So a vector may be given by magnitude of the vector multiplied by the unit vector. So you have given the current first, that is equals to 0.25 ampere. Now this is amplitude of the vector or magnitude of the vector, that is equals to given 4 into 5 into 10 ki power minus 4 meter square. Yes, this is important. You have given this is 4 centimeter and this is 5 centimeter. So first convert it into the meter. So 4 into 10 ki power minus 2 meter length, and this will become 5 into 10 ki power minus 2 meter. Now multiply them. So you will have 4 into 5 into 10 ki power minus 4, because 10 ki power minus 2, 10 power minus 2 become 10 ki power minus 4. Clear? And finally, you have the normal vector, normal unit vector, that is equals to this one. Clear or not clear? So you will have the finally magnetic moment as this 5 into 10 ki power minus 4 ampere meter square. Clear or not clear? Now, then after you have to find the torque. What is the value of torque? You know, torque is equals to, vector torque is equals to mb sine theta, and direction is along n cap. Clear or not clear? So mb sine theta n cap, but we have given the vector as resoluted component, so we have to write m vector m vector cross b vector. Okay, m vector cross b vector. What is m vector? This is our m vector. And what is b vector? B vector is given in the question. This is magnetic field 0.20. It is made more complicated, but you have to write only 0.2. No meaning of 0 after the decimal points. So this one. And the unit of the torque equals to Newton meter. Clear? Now multiply with the vector rules. Okay, see here we have the vector rules. First, during cross product, remember cross product I cap cross I cap equal to 0. Yes. So both we are discussing here, dot product and cross product and cross product. Clear? So what is dot product? Dot product I cap dot I cap equals to j cap dot j cap equals to k cap dot k cap equals to 1. And different vector I cap dot j cap equals to j cap dot k cap equals to k cap dot I cap becomes 0. Okay, the perpendicular vectors giving the dot product 0. Now here I cap cross I cap equals to j cap cross j cap equal to k cap cross k cap equals to 0 vector, because cross product is also called vector product. So the two vector must have product as a vector quantity, so they will give you 0 vector. Clear or not clear? Next, I cap cross j cap equals to k cap, and j cap cross k cap equals to I cap, and k cap cross I cap equals to j cap. So they using the Maxwell rule of like this. This become I cap. Now here it is j cap, and here it is k cap. Okay, you must have learned this in class 11th. When I cap is moving towards j cap, it will produce k cap. When j cap is moving towards k cap, it will produce I cap. Okay. And it's reverse. When j cap is moving towards I cap, it will give you minus k cap. J cap cross I cap equals to minus k cap. Okay. Okay, so let's multiply. In what way we have to multiply? First, see here 0.8 multiplied by 0.2. So 0.8 into 0.2, that is equals to 0.16. Now I cap moving towards j cap, so it will produce plus k cap. Clear or not? Then I cap multiplied by 0.8 into 0.5, that will give you 0.4. I cap towards k cap. Now I cap towards k cap will give you minus j cap, because I here, j is here, and k is here. Okay. Yes. So when you move clockwise, you will have positive result. But when I cap is moved towards k cap, it will give you minus j cap. Got it? Now minus 0.6 j cap into j cap. Now j cap becomes 0, because cross product will give you the same result, 0. Clear? And 0.6 minus multiplied by plus 0.5 k cap. Okay, 0.6 into 0.5. 6 5s are 30. So it will be 0.3, and j cross k equals to how much? Say 0, this will be j cos k equal to positive k cap, but j cos k, sorry, equal to I cap, positive I cap, but one negative is here. So it will give you minus 0.3 I cap. Clear or not? Yes. Check. J cap cross k cap. If j is moving towards k, if j is moving towards k, then it will give you plus I cap. Okay. But here it is minus 0.6 multiplied with 0.5 plus. So if minus is multiplied with plus, this will give you minus. Okay. So it is equals to minus 0.3 I cap. Clear? Now write it properly. First it is I cap, then it is j cap, then it is k cap. Resoluted vector. So it will answer 5 into 10 to the power minus 4 is minus 0.3 I cap minus 0.4 j cap plus 0.16 k cap Newton meter. Done?